Thanks very much, Helena. I'm Anna Rose Prynne, as Helena was saying. I'm from Extinction Rebellion Bridport, and I've been involved with Extinction Rebellion probably from about the time at the end of last year when they made the Declaration of Rebellion, if you remember seeing that on TV. They sort of blocked Parliament Square for a short while with a number of people, and more people than they anticipated. There were about 1,000 people who came along, and they made the Declaration of Rebellion. And I can remember seeing that at the time. I'd been getting, over the years, increasingly worried, as I'm sure a lot of you have, about some of the news that was filtering through, usually kind of about sort of like specific things, so in dribs and drabs, things about kind of warming, about ocean acidification, the corals, things like that. They would come in kind of like piecemeal, if you like. And I was kind of, you might kind of relate to that feeling of cognitive dissonance when you would see these things on the news and think, well, this sounds very serious, but nobody was really talking about it in a way that made it sound serious. And so there was a sort of feeling that, oh, well, we can just sort of ignore it, really. When Extinction Rebellion made the Declaration of Rebellion and I saw that, I sort of like thought, finally, this is an organisation which is telling the whole truth and which is bringing all of these things together, and I think has a really, really good chance, a better chance than anybody so far, of turning all of this around. So that was how I got involved, and then I very quickly knew that once I'd seen this talk myself, I knew that I wanted to be a speaker for Extinction Rebellion and be instrumental in spreading the word, really spreading the motivation of what we could do to turn all of this around. So the talk that you're going to hear today is the official Extinction Rebellion talk, if you like. It's kind of been done all around the country. It's still being done all around the country. It has gone through a sort of few changes as time has gone by, but it's essentially the same message. So who are Extinction Rebellion? Well, basically, Sarah will tell you a lot more about Extinction Rebellion later, but to put it very basically, we're a non-violent, direct action civil protest organisation, and we're made up of ordinary people, ordinary law-abiding people. I'm a writer and a prisons monitor. You get doctors, shop workers, street cleaners, lawyers, teachers, you name it really, can all be part of Extinction Rebellion. So we're normal citizens and not particularly rebellious, but we have decided to rebel, that what we need to do is rebel. And in essence, the reason for that is to try to save humanity from extinction, no more and no less. Because...
I'm really sorry to interrupt, but do you think you can switch the lights off?
Oh, yes,
slides are quite
yes,
faint.
really sorry.
That's the only thing.
Yeah, the lights are all out there.
Are they?
Sorry, we'll just have a brief sort of check the... They're out there. There we are. Is that better? Can people see now? We might have to... Can you still... Is that still all right for you?
You're much darker.
Okay. Okay. Yeah, it's a bit more difficult to see my page as well, but yeah. Okay. So, yes, because it is clear to us, and this is backed up by science, as I'll go on to explain, that is what we're facing if we stay on our current course. We're facing... Extinction Rebellion is convinced, certainly the end of human civilization if we stay on the current course, and maybe species extinction. The problem being that as a society for a very long time we've been in a kind of collective denial about the extent of the climate and ecological problems that we're facing. And this denial We've known for decades, I mean, a lot of us, I'm sure, are very assiduous in keeping ourselves informed. We've known that there are things that have been going wrong, greenhouse gases, deforestation, plastics, etc. But there's been a dissonance, as I was saying. Denial is a useful thing in some respects, in that it helps us to carry on functioning day by day when you're facing something that sort of seems almost too big and too overwhelming to cope with. If you thought about it all the time, you just wouldn't be able to function. And so denial's quite helpful there. And then, unfortunately, it becomes much more comfortable to sort of stay in denial, to stay in that zone of denial. I mean, I'm sure that you've kind of wanted to discuss these things sometimes, and people have said, oh, don't talk about that, it's too depressing. And you feel that there are only certain people that you can actually discuss it with. And then on TV, for example, on the media, you get things like in February, when we had a record-breaking day of temperatures for February in the UK, and the TV was sort of presenting this as if this was great. Britain basks in balmy weather for February, showing pictures of parks with blossoms and people sort of frolicking about. There's something kind of denial about that. And denial becomes dangerous when it stops us from taking action on things which are existential threats. At that point, it becomes dangerous. And the way to overcome denial and enable ourselves to act is to confront the realities of what's going on. And unfortunately, that is an emotional and frightening experience. And it's a necessary one if we're going to enable ourselves to take the actions which are needed. So I want to thank you for coming here today to face the truth about the climate and ecological crisis. It's a day when our Prime Minister taking a decision to prorogue Parliament is somewhat overshadowing some of the other critically important things that are going on. The Amazon is burning, koala bears have been declared functionally extinct. There are billions of tons of water a day pouring off the Greenland ice shelf. There's been a massive freak hailstorm in southern Madrid, which has kind of caused massive torrential flooding. And these things are sort of like going on right now at the moment. And so while this is going on, and despite all of this happening now and being in the news daily, a lot of people still do not have the courage to look that in the face and confront the reality of what's happening. So thank you for being here to do that. These crises do bring up a lot of different thoughts and feelings, and it's important that we don't feel alone in dealing with these. Those of us who've been thinking about this for quite a long time have had to kind of really adjust our view of life, our view of the future, our expectations accordingly. But if some of this information is new to you, some or maybe most or all of the information is new to you, you might find yourself experiencing some of these unpleasant emotions. And I want to assure you that these are normal and perfectly appropriate given what we are facing. But you might also feel relief that it's being talked about and spoken about honestly. And in fact, people who join Extinction Rebellion, myself included, can find the experience of joining a movement and joining with action to be therapeutic almost and empowering. Before we get to the main body of the talk, I would like us to take the first of what are two pauses that we're going to have this evening. And this one is to just turn to your neighbour and especially if it's not somebody that you have come with, so somebody who's new to you, and just have 2 minutes, 1 minute each side, to just talk about what has brought you here tonight. I'll time you and then I'll kind of start waving my hands about at the end. Okay, thank you. Thank you very much. main talk is in two parts. The first part is where we tell you the truth about the climate and ecological crisis. So we look at the science and at the prospects for the future if we don't change course. And then the second part of the talk looks at Extinction Rebellion and the plan for action to turn it all around. So first of all, we're going to have a look at the ecological crisis. We need to remember really that the Earth is our only life support system. I mean, that seems kind of like obvious to say, but as some people say, there is no planet B. This is it. This is our life support system for us, our children, our grandchildren. Everything that we need for life is basically contained on the surface and in the biosphere of this planet. Well, we're in the process of destroying that life system. We're destroying its climate. So we're destroying what has kind of like kept us in a sort of stable situation of temperature for very, very many years and enabled us to have agriculture and all the things that we need. And we're destroying its ecology. So we're destroying the web of living organisms that basically kind of consist of the life on Earth. And in doing so, we are destroying our future. So we really are looking at the end, certainly of human civilization, and maybe if we take things too far, at the end of humans as a species at extinction. And we, because of our intelligence, are probably the only species in the 4 billion year history of the Earth that has ever understood its imminent extinction. And so if any species can stop its own extinction, it's us. The question is, can we? I mean, I think that yes, we can. The other question is, will we? So first of all, we're going to have a look at what's happening to the climate. And first of all, there's a basic description of warming, so forgive me if some of you are very familiar with this. But basically, yes, greenhouse gases keep the Earth warm. Heat comes down radiated from the sun. When it kind of comes through the layer of greenhouse gases, of which carbon dioxide and methane are the most important, but not the only ones. Some of it can irradiate back into space, but the sort of like shroud, if you like, of carbon dioxide and methane keeps some of the warmth there. And in some respects, that's quite good, because if it didn't keep any at all, the Earth would probably be a ball of ice. But what's happening now is that we've been pumping greenhouse gases into the atmosphere at such a rate that the Earth is getting hotter. The shroud of carbon dioxide and methane surrounding the Earth is becoming denser, and it's not allowing so much heat to escape, and so therefore the Earth is warming up. Over the eons that the Earth has existed, of course, the atmosphere has gained and lost carbon dioxide, has gained and lost greenhouse gases, and paleoclimatologists have found that the climate is heated and cooled pretty much in sync with how much of a level there is of these gases in the air. So it's a very potent regulator of the climate, and we do now know that an increase in the level of these gases in the atmosphere causes the warming of the Earth. But what's been happening is that we've been pumping these gases in at a completely unprecedented rate. So when we entered the Industrial Revolution, we started exploiting fossil fuel reserves to obtain the energy to build our industrial civilization, and indeed to develop the very comfortable way of life that we had now. But it has come at an enormous cost, because in doing so, we've intensified the greenhouse effect, and now the Earth is very rapidly getting hotter. This is a graph that rather alarmingly shows the rate at which that has been happening in recent years. For at least 2,000 years, as long as this graph covers, we've had a pretty level, stable amount of carbon dioxide in the atmosphere, regulated by living things, so plants, phytoplankton, etc. They absorb a certain amount, they give off a certain amount of oxygen, and so they keep it going in a sort of dynamic equilibrium. Here, as you can see, sorry, I'll get out of your way, where that blue line is, that arrow pointing, that is where the industrial age begins. So as you can see, after all of this time of the levels being pretty stable, it suddenly starts rocketing upwards. And in recent years, I don't know if you can see this last black line in the graph, which is the year 2000, it starts going up absolutely vertiginously. Not surprising then, given the correlation that we've discussed, that's having an escalating effect on the temperature of the Earth. Temperatures have risen more or less in parallel with the rise in the greenhouse gases. There's the line, that green line denotes 1 degree of warming above pre-industrial levels, which actually they've put above as 1880 there, which isn't exactly pre-industrial. But as you can see, we've burst through that line, and there in 2016 we were on about 1.1 degree of warming above in pre-industrial levels. And it's still kind of like going inexorably upwards, and there are some fairly credible studies, for example the Breakthrough Centre in Australia, which think that on that trajectory, if it isn't turned around in some way, we're looking at about 3 degrees by the middle of the century. So in about the 1980s, scientists actually managed to start convincing politicians that we had a big problem here, that there was a problem that needed monitoring and needed addressing. And so the IPCC was formed, the Intergovernmental Panel on Climate Change. And their brief, basically, was to gather, harvest all of the scientific evidence, so all of the scientific peer-reviewed papers on the issue, and then review them and come up with, establish the current scientific consensus and produce a report. Every few years they produce a report. Their last report was in November last year, and this report concluded that anything beyond 1.5 degrees of warming above pre-industrial levels would have a catastrophic effect, catastrophic consequences, and in many cases irreversible effects on the planet and human societies. And it made a recommendation for CO2 emissions, or greenhouse gas emissions, to reach net zero by 2040 globally. Currently, they are still rising. They haven't slowed down their rise, they haven't stopped. They are still rising, as you could see from that graph. The heads of most world governments got together and agreed in the Paris Agreement to aim to keep global temperature increases below 2 degrees, even though the IPCC recommended 1.5 degrees. The Paris Agreement, even with the 2 degrees, it's not legally binding. It's a voluntary agreement, and as you're probably aware, when President Trump came to power in the US, he pulled the US out of the Paris Agreement. The IPCC have essentially said, or they said last year, that we've got about 12 years to try to sort of like start turning this around. They don't mean 12 years before the world ends, obviously. It's 12 years for us to make significant progress to try to stop the trajectory that we're on. And some of the scientists, politicians, delegates at that IPCC conference were using language like this. It's a deafening smoke alarm going off in the kitchen. We have to put out the fire. Climate change is reaching the end game. What we're talking about is the collapse of our civilization. It's a line in the sand. We have lost time. We have to act now. This was last year, and this was what people were saying at the IPCC. I have to kind of like explain 1.5 degrees doesn't sound very much, does it? In terms of kind of like from one day to the next, it sounds like nothing. But what we're talking about is an average, a mean temperature rise here. And 1 degree of warming generally can mean in some places and at some times you're looking at up to 10 degrees warming. It just increases what's happening at the extremes. The temperatures at the extremes, the length of time the temperatures stay high at those extremes. And we are already seeing some of that, unfortunately. And it is also true that even a very small temperature change can very badly affect delicate habitats and fragile species. And sometimes you'll hear people say, well, the Earth's always gone through cycles of heating up and cooling down, hasn't it? So that's just what it's doing now. It's nothing to do with us. So what's the problem? I mean, apart from the fact that I think we've shown that greenhouse gas emissions and our activities concerning it do show that it's very much affected by our activity. If you actually look at sort of what's gone in history, for about 11,000 years, we've had a very, very, very stable temperate climate. If you see it on a graph, it's almost like a straight line. And that's been called the Holocene. And it's a period in which human civilization has developed. We've been able to sort of like build cities, spread around the globe, start agriculture, etc. All of that kind of thing. And we have, you know, it's a temperate thing. We have extremes. We have ice at the poles. It's hotter at the equator. But in between, it's kind of inhabitable and stable. So the last time that temperatures were 1.5 or 2 degrees higher was about 130,000 years ago, long before human civilization. And for higher temperatures still, 3 or 4, you're looking at millions of years ago, literally millions, before humans even evolved, basically. And so human civilization has not existed on a heated Earth, and there's plenty of evidence to suggest that it can't, that it would not be able to adapt. So we're pushing ourselves out of the Holocene, in fact, and into uncharted and very, very dangerous territory. So, at 1.1 degrees, as we are, above pre-industrial baseline, we're already starting to feel a lot of the effects of climate change globally. You've probably been aware that in the last few years there have been a huge increase in news about really devastating weather events. There have been extreme flooding events. I hope I'm not blocking anybody. Over here, this is in Queensland, Australia. There was a very long and very deadly drought and heat wave when it went on for quite a long time, and it was disastrous. There were birds and bats falling dead out of the sky and out of the trees with heat stress, and wild animals, wild horses, for example, were found dead around empty water holes. It was a really terrible drought, and it ended with a catastrophic series of heavy rain events which caused massive flooding, and about 150,000 cattle were killed. There've also been other heat waves. So over here, this is the city of Chennai in India, and I believe that that's a very recent picture. The city of Chennai, a modern city, ran out of water. It has run out of water. Water is having to be brought in by tankers to try to fill the needs of the population. And elsewhere in India, there are areas where the temperature has rocketed to about 50 degrees, which is almost unimaginable. I mean, that is almost uninhabitable. Crops have died, nothing will grow, livestock have died, water has run out, people have had to move. They've had to move away from the areas where they live to escape the heat. And then down here, this is a picture of the aftermath of one of the wildfires in California. Again, that was a lot in the news. The number of hectares destroyed by wildfire in California over about the last decade has increased by about 62%. And about this particular one, about 85 people were killed. Lots more were made homeless and had to flee their homes, and the town of Paradise was completely ravaged by fire. And you're probably aware that there are a lot of fires going on in all sorts of places around the globe that you wouldn't expect to be seeing them at the moment. And here we have the aftermath of Hurricane Idai in Mozambique. This was last year when Hurricane Idai caused major flooding over a massive area. Again, it displaced millions of people, I think. It made hundreds, it killed hundreds, made people homeless, vulnerable to disease, and was generally quite a disaster. So we're already starting to feel the effects more and more frequently of the heating climate globally. And even here in the UK, in 2004 there was a big heat wave all over Europe. It affected the UK as well, but it was implicated in the deaths of 70,000 people. Now, if there was like a terrorist attack and 70,000 people were killed in it, I mean, everything would spring into action. The geopolitical globe would be sort of knocked off its axis, basically. But when there are kind of like slow, lethal events, we don't sort of seem to fear them as much, because I suppose as animals we're kind of like programmed to have an adrenaline response when there's a very sudden threat, when something very sudden happens. So when there's something which is equally destructive, we don't necessarily fear it enough to take action. In 2014, we had the worst rainfall in the UK for 248 years. And in 2019, there was a decision that the village of Fairbourne in Wales was going to have to be decommissioned soon. It hasn't happened yet, but that was the decision. And this is because of sea level rise. And basically, if they do have to move, the villagers of Fairbourne will be the first UK climate refugees. In 2018, we had the hottest summer on record in the UK. Record numbers of people went to accident and emergency, with a rise in heart failures, kidney failure, dehydration. Heat-induced kidney stress is a massive growing problem that health providers in hot countries are facing, and also vegetable yields fell by up to 50% in some parts of the UK. So we are in no way immune from that. So what happens if we carry on heating up the earth and don't take any action? When I say carry on heating, it's not like the heat's going to reach a particular not very tolerable level and stop there. It's going to carry on. It's going to carry on, and in fact it's going to trigger itself to carry on heating, as I'll kind of discuss later. What happens if we don't change course? This is kind of called the business as usual scenario. So we just carry on what we're doing, and then, well, it's pretty predictable, and there are lots of ways that scientists can make these predictions. We're going to see sea level rise, partly due to thermal expansion of the ocean. Water expands when it warms up, but a lot of that will be due to the melting of the ice caps. There are billions and billions of tons of ice locking up water at the poles, and if it were all to melt, suddenly, which won't happen of course, then our sea levels would rise by maybe 100 to 200 metres. And it has actually done that in the past, but it won't happen overnight. But by the end of the century, on the path that we are on, we are looking at the sea level rising by 1 or 2 metres. If you think about the number of coastal cities that there are in the world, there are going to be lots of people who then become more climate refugees. They would have to be evacuated. Dwelling places would be so badly affected. And as a side issue of that, we would also lose a very great deal of low-lying farmland, so low-lying food-producing land, which would augment those problems. So we'll see coastal flooding, and we'll see storm surges. There'll be stronger atmospheric weather systems, as we are already seeing, of course, as we've already looked at and discussed. Strong storms, droughts, wildfires, desertification, crop failure. There will be an increase in deaths due to heat stress. And when these famines, water shortages, displacement of people from their homes all start to happen, history has told us that this kind of destabilisation is inevitably going to lead to a growth in authoritarianism, authoritarian government, and then to armed conflict. It's actually probably more likely that people will be killed as a result of conflict when it sort of becomes obvious that people are in more competition for land and for water and for resources than it would of them then dying of the effects of climate change. And this is, of course, a planet full of nuclear arms. And so the consequences for business as usual are really, really dire. And this is assuming that, from what we know is already happening, it's assuming a linear rise. It's assuming a linear rise in the heating of the planet. But unfortunately, it's likely that we're looking at an accelerating effect, so the heating becoming exponential, in other words. We know that there are certain amplifiers of climate change. For example, feedback loops to do with the effects of ice. There's still quite a lot of ice at the poles. We're melting it at quite a rate, as you can see. Those pictures are the same day in September, well, a day apart. The first one is 1984, the second one is 2012. So we can see that that is declining, but nevertheless, at the moment, it still provides a function of a cooling function for the planet, if you like. The sun's rays come down, they hit the white ice, a certain amount of them gets sort of like deflected back into space, and in that way, the Arctic ice keeps its own environment, and it also helps with the cooling of the planet in general. What happens when the ice starts to melt through warming is that dark land, dark water gets revealed. Less of the sun's rays are deflected back, and then that means that the area around the ice then warms even more, and so it just kind of accelerates the rate of warming like that. Less ice, more warming, less ice. So it happens like that. And then it's unfortunately true that the poles are warming faster than any other part of the planet. They're warming at about 3 times the rate of the rest of the planet, to an extraordinary level. The current temperature is 30 degrees above what it should be for this time of the year, and the Arctic summer is the hottest it's been for 10,000 years. An additional danger from this is that the permafrost and the sea ice at the poles are locking in some unknown number of millions or billions of tons of methane. And methane is a greenhouse gas that is many, many more times more powerful than carbon dioxide. We don't know quite how much there is or how much of it is going to be released, but as the permafrost and sea ice melts and it gets released, it has a very strong potential that it will vastly increase and accelerate global warming. So that curve on the graph earlier may actually become very, very much steeper. Unfortunately, there has been some visual evidence that the permafrost is starting to melt, and that is 70 years before it was predicted to start melting. There's not just 1 or 2 feedbacks, however, but there are many. Some of them we understand quite well, some of them we understand less well. There was a paper last year, in 2008, that was published that's become known as the Hothouse Earth Study, and it caused a great deal of shock. it proposed that these feedbacks can influence each other once they reach a tipping point. And then when they reach the tipping point, they trigger other tipping points to kick in, and then that becomes known as a tipping cascade. So all of these interdependent systems all start collapsing like a set of dominoes. And the authors predict that if we reach this threshold, we then find ourselves going down what's known as the hothouse Earth pathway, in which our whole planet just shifts towards a hotter climate and profoundly different and diminished ecosystems. And in the words of the authors, beyond the threshold, which is potentially 2 degrees, but it could be 1.5 degrees, feedbacks outside of human influence or control could become the dominant driver. So given the devastatingly high impact risks involved, it seems that it would be prudent to stay on the safe side of the scientists' recommendations for emissions reductions. So that was the climate, but the climate is only one half of the problem. The other half is the biosphere that I mentioned, the ecology, the shell of living things that sustains us. The organisms live both on the land and in the oceans, and human activity is managing to destroy both of those things. There was another report to the UN. That was just in May this year. It was the IPBES report, which is the snappy title of the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services. But basically, as the IPCC is to climate science, IPBES is to the ecology. And it was a very, very damning report. And these are some of the things that it said, which I'll read to you because it's probably a bit too small to see. We're eroding the very foundations of life worldwide. We have lost time. We must act now. Nature is being destroyed at 10 to 100 times higher a rate than average over the last 10 million years. Natural ecosystems have lost half their area. Humans affect 3/4 of land, 2/3 of the oceans, 3/4 of fresh water, leaving really very little room for anything else. And 1 million species are at risk of extinction. That thing about the natural ecosystems, it's not just for them in themselves and them being sort of like pretty and it being nice to have the species in those habitats. They are also the systems that protect us from climate change. So we're destroying the nature that protects us from climate change as we cover it over with our cities, with our infrastructure, with our intensive farming. Talking of which, one of the big drivers of land use has been the need to grow enough food to support 7.5 billion humans. 7.5 billion and rising rapidly. In order to feed that many humans, especially with their appetite for a diet very high in meat and dairy products. We've deforested huge amounts of land and replaced it with monocrops and beef cattle. Agriculture uses a great deal of land that would otherwise be forests or natural grassland, and intensive agriculture swallows up smaller, more sustainable and more biodiverse farms. It also requires heavy use of pesticides to keep insects at bay and prevent them from destroying crops. But pesticides have caused a catastrophic decline of insects worldwide. It varies from place to place. A study in Germany said they'd lost 2/3 of their insects. There was a study in Puerto Rico where they had lost 97% of their insects. But even a fairly conservative estimate says that we're looking at the extinction of 40% of the world's insect species over the next few decades. Well, insects are needed for pollination. They support many food webs, so they're at the bottom of many food chains, including those of which we are at the top. If we lose pollinators, such as bees and butterflies, then many plant species die out, and that includes many species that we depend on for food. The forests that a lot of this is replacing are very intense carbon sinks, very efficient carbon sinks. So there are plants which grow very rapidly, pull a lot of carbon out of the atmosphere and turn it into plant material. The plant material dies, forms soil, and this more or less locks up the carbon. And because the trees are respiring, so they're metabolizing and sending out water and maintaining a moist climate, you get a lot of rainfall around a forest area, which is able to sustain many life forms, biodiverse life forms. And again, it keeps its, like the Arctic, it keeps its own ecology going through doing this. So where there's a rainforest, there's a lot of carbon drawdown. There's a lot of oxygen production. There's a lot of moisture. So natural, healthy forests are vital to our survival. When we burn those forests, we take that carbon that was locked up in the trees and we release it up into the air. And then when we replace it with crops, we're essentially replacing this very diverse system with a monoculture. And I have to say a little bit about the Amazon here. Nobody can be unaware, I'm sure, that the Amazon, large swathes of the Amazon are currently on fire. There was a study a while back that said for the Amazon to sort of keep its integrity as a rainforest, it needed to be preserved in a particular amount. This study, I think it was in 2014, when we'd already lost an area the size of Germany. So we'd lost 20% of the forest. And this study said that when destruction of the forest reached 40%, it was going to reach a tipping point where it essentially stopped functioning as a rainforest equilibrium and would instead be functioning as a savanna equilibrium. At that point, we've lost it as a carbon sink. Instead, it becomes a carbon emitter and it gradually becomes desertified. Obviously, with what's happening now, some of these fires have been purposefully set in order to deforest the Amazon to keep going the kind of meat production and animal feeding systems which our diet depends on. Obviously, that point is going to be reached a lot sooner. At the time of the report, they thought that it was going to be about 40 years, and then if nothing had changed, the Amazon would reach the tipping point and we would essentially have lost it as a functioning forest. It looks as if, with what's going on, that might end up being sooner than that. The end result of the process, of course, is that you take a forest and you turn it into a desert, which has a very low ability to sustain life and is very difficult to reverse because you have essentially removed all the moisture from that region. There's something that people say, and I must admit that I used to kind of like cling to it and find it a bit comforting as well. They used to say that the planet will be okay without us. Once we've died off, all nature will be fine, it'll all sort of surge back again, and everything will be lovely, so it'll be fine once we've died off. I'm afraid that we can't get out of our responsibilities to the planet quite so easily, to the planet and our fellow creatures and ourselves and future generations. The planet might survive as a spherical rock object in space, but that might be about it. If you look at Mars, Mars is a dead red planet, but there's evidence that at one point Mars was fertile. There was water. It was a planet much like Earth. If these kind of systems start happening, it could be many, many billions of years, if at all, that the Earth becomes a planet recognisable to us as it is now again, to recover, if it does at all. It's not just the land. Oceans are equally vital to our survival. They're similar to forests in that they are a carbon sink and an oxygen source. Water dissolves some carbon dioxide, and also there are a lot of photosynthesizing organisms such as phytoplankton, which are pulling carbon out of the air and locking it up in the oceans and producing a lot of oxygen, which supports the marine life. And of course, they supply a great deal of our food, the oceans. There are communities that depend on them, and billions of humans rely on them as a main source of nutrition. So the oceans are a very important life system. Water also has a very high ability to absorb heat. So a lot of the heat that we've been pumping out has actually been absorbed in the oceans. So to a certain extent, they've shielded us a bit from the effect of greenhouse gases. But once it gets to a certain point, the effects that we've experienced on land then sort of start to become experienced in the ocean. There's been evidence of heat flashes through the ocean, areas where phytoplankton have been killed. The oceans then become acidified. The photosynthesizing process, once it gets to a certain heat, really sort of ceases to function. And this causes, obviously, changes in the distribution of marine life. But it also causes changes in the ocean currents. It changes the circulation, because a lot of the circulation of the ocean, which maintains the climate, is driven by temperature differentials at the poles and the equator. And when we mess with that, what we're doing is essentially changing the currents, and those have somewhat unpredictable effects on what is going to happen with the climate. And actually that graph showing the way that the temperature has gone up is really quite alarming. So, measurements of global biodiversity are showing that we're experiencing a dramatic decline in species worldwide as a result of human activity, including the climate heating and habitat destruction that we've just looked at. But of course, we also purposefully kill creatures because they get in the way of our developments, because they're considered pests, or sometimes just for fun. 1 million species threatened with extinction, the IPBES report said. The rate of extinction has been estimated at being 100 times at the moment what's expected. So there's a base rate of extinction, there's a rate of extinction, that things go extinct all the time. They did before humans existed. But yes, it's about 100 times more at the moment. And this is leading scientists to conclude that we are actually in the midst of the 6th mass extinction of planet Earth. The 5 previous extinctions were also due to dramatic changes in greenhouse gases, by the way, in the atmosphere, probably from volcanic activity. And of course, one of them caused by the asteroid which precipitated the extinction of the dinosaurs. But while life in general adapted to these changes, individual species generally did not. And furthermore, these changes tended to occur over thousands or millions of years, while the warming we're currently experiencing is at a rate not seen even in the worst past extinction, which, by the way, was the Permian mass extinction about 600,000 years ago, in which 97% of all life on Earth was killed. So we as a species are in danger of precipitating temperature rises to which we cannot adapt. Most of the collapse in ecosystems that we're seeing currently has taken place in the last 50 years, in just the last 50 years. If you sort of think of how long humans have existed, that's quite frightening. Those of us who are adults today came into a world that was still rich with biodiversity and wonderful habitats, with many megafauna or large animals, natural landscapes that we've enjoyed and which have enriched our lives. Our children are experiencing a much reduced world in which natural unspoilt landscapes are rare, wild animals and insects are becoming hard to find, and most life is lived in separation from nature. I mean, if you look at that, that's like, isn't it? It's beautiful, the colours. It's kind of like a page from National Geographic or something. Tiger, polar bears, elephants, puffins, monarch butterflies. They are all endangered, all of them. Our grandchildren may never know the animals that we take for granted, such as these. And more shockingly, they might not know things such as butterflies, frogs and lizards. All of those are in decline. So we're stripping the planet of its life, and once it's gone, we cannot get it back. What we're doing has been called Burning the Library of Life. Yes, looking at those species again that are all endangered. By biomass, mammals in the world consist of 60% livestock, another 36% human beings, and only the remaining 4% by biomass is wild animals. So you could replace all those pictures if you were going to show children an honest picture of what the world looks like. You could just do away with that and show them a montage that goes cow, cow, pig, human, cow. That would be a more honest picture of what the world looks like at the moment. I find this particularly affecting, and that is the fact that from 1970 we have lost 60% of our individual mammals, birds, amphibians. 60% of the individuals, that's how much their numbers have gone down. That's not species or biomass. And I find that particularly appalling because in 1970, when these measures started, I was 10. For my 10th birthday, I was given my first pair of binoculars, and I was given the Oxford Book of British Birds, which I've still got in pride of place with a very, very battered cover now. As soon as I got those things, I was absolutely mad about spotting and identifying birds and ticking them off the list. And this lasted into adulthood. I'd take any opportunity I could to go to reserves, to go bird watching. It was a very, very important part of my life. With what I know now, I know that if I had known that back then, I would have known essentially I was watching them die. I was watching them decline. I was watching us lose 60% of them. And that really hurts, actually. So the very rich world that we came into, that's full of the tigers and elephants, etc., and all these things that children love, a world full of animals, they're not going to have that. And our grandchildren, if we have grandchildren, will have even less of that. So we've taken a rich world and we've stripped it of its richness, and we're turning it into an impoverished, infertile planet. And not only that, but in doing so, we're destroying the very things that keep us alive. I mean, you could say, does that matter whether we've got these animals, etc.? Of course it matters. Absolutely it matters. And it matters partly because these things, if they go, we will follow them, essentially. And we have about 30 to 40 years to turn that round before we pay a very, very high price. Remember the food webs, the pollinators, etc. We depend on having a very rich and biodiverse wildlife in the world. It's like really soaring off the branch that we're sitting on, not only the evolutionary branch, but also the branch which is just vital for our survival, and we're going to crash to the earth. And put like that, such recklessness is very, very hard to countenance, I think. I find it very hard to countenance. Personally, I think that I feel that it's bad enough, very bad, very, very bad, that we're doing this to ourselves, that we're doing it to future generations, but that we're taking the rest of the life on the planet with us, all the sort of innocent species which, you know, haven't caused this of themselves. That seems really, really egregious, I would say. So this is the end of the part on the facts behind the ecological crisis, and I'd like to thank you for listening, because I know that some of that can be very, very hard to hear, and it's quite hard to repeat, actually. We're going to have a moment now, another of the pauses that I mentioned, to again share with your neighbour. You might want to at first just sit for a bit and just kind of digest what you've heard and get in touch with what you're feeling about it, and then maybe discuss it with the neighbour that you spoke to earlier. And then we'll come back and Sarah will tell us about what we intend to do about it. Thank you.